In this video, we are going to define various operations that we can perform on sets. The purpose of these operations is that we can use them to create new sets from old ones. Often, we will work with subsets of a specific set, which we call universal set. And it's quite frequent that universal sets are denoted by the letter U. So suppose we are given a universal set U, and we have a subset A of U. Then the complement of A, which is denoted by one of these two notations, is the set of all elements of U which are not contained in A. So, for example, in our set notation, the complement of A is the set of all X in U such that X is not in A. For example, if the universal set contains the elements 1, 2, 3, 4, and 5, and A contains the elements 1 and 3, then its complement contains the elements 2, 4, and 5. As a warning, this complementation is always taken with respect to a universal set. In the above example, if A was as before but the universal set changed to the set containing 1, 2, 3, and 4, then the complement of A will now be the set containing 2 and 4, and it wouldn't contain 5 because now the universal set doesn't contain 5. Another set of operations that we are going to define, given sets A and B, their intersection, which we denote with this notation, is the set containing all elements which are contained in both A and B. In our set notation, the intersection of A and B is equal to the set of all X, such that X is in A and X is in B. For example, if A is a set containing 1, 2, and 3, and B is a set containing 2, 3, and 4, then their intersection is a set containing 2 and 3. In the case that the intersection of A and B is empty, then we say that A and B are disjoint. New operation that we want to define is the union of two sets A and B, which is denoted with these symbols, and it is a set containing all elements which are contained in at least one of A and B. In our set notation, the union of A and B is the set of all X, such that X is in A or X is in B. For example, if A is the set containing 1, 2, and 3, and B is the set containing 2, 3, and 4, then their union is the set containing all of 1, 2, 3, and 4. New warning, in the set notation here, we use this word OR, and in mathematics, this word is always used inclusively. What means here is that if X belongs to both A and B, then it is included. It is included in the union. So often we use Venn diagrams to depict these set operations we have just introduced. So what are these Venn diagrams? They are pictorial representations of sets and the various intersection relations between them. So they are usually composed of overlapping circles inside a rectangle, with one circle for each set we are interested. And the interior of each circle represents the elements of the set, and the exterior represents the elements that are not members of the set. For example, the Venn diagram for the complement of A is drawn as follows, because the interior of the circle represents the elements of A, and the exterior of the circle represents the elements which are not in A, i.e. the elements of A complement. So here are Venn diagrams for the intersection, all elements belonging in both A and B, or the union, all elements belonging to either A or B. So another set operation is that of a set difference, which we denote like this, and is the set of all elements which belong to A but do not belong to B. So in set notation is the set of all X such that X is in A and X is not in B, and it's only in the Venn diagram is only this part of the circle. And so for example, if A contains the elements 1, 2, and 3, and B contains the elements 2, 3, and 4, then A set difference B is the set containing only 1. And of course the set difference B minus A is defined analogously. And of course we can also work with more sets. For example, the intersection of A with B and then taking the union with C denotes all elements of X for which X belongs to both A and B, or X belongs to C, and it's depicted in the following diagram. Either it belongs to C, or it belongs to A and B, and of course, if it belongs to both A and B and C, this is also allowed.